Imagine you're playing basketball and now you're going to shoot the ball into the hoop to get the points. While throwing, if you observe the path of the ball, it arcs up into the air and then comes down. This shape is called as parabola. We can see this shape in so many places like satellite dishes, the shape of a banana, in the rainbow, bridges, etc. Let's discuss about the parabola and its aspects detailed in this video. Let's start the concept with the definition of parabola. What is parabola? Parabola is a set of all points in a plane that are equidistant from a fixed point and fixed line in the plane. The fixed point F is called the focus of the parabola and the fixed line is called the directrix of the parabola. Here we can notice that P1, P2, P3 are the three different points on the parabola which are at the same distance from the fixed point F. Similarly, B1, B2, B3 are the points on the fixed line which are at equidistant from P1, P2 and P3. Therefore, we can write P1F is equal to P1B1, P2F is equal to P2B2, P3F is equal to P3B3. We should be clear that the fixed point should not lie on the fixed line. If fixed point lies on the fixed line, PF will not be equal to PB and this is called the degenerate case of parabola. And the next term one should know about is the axis of parabola. What is axis of parabola? A line through the focus that is perpendicular to the directrix is called the axis of parabola. The point of intersection of the parabola with the axis is called the vertex of the parabola. And these are the few basic terms related to parabola. Now, here is a diagram. You can have a look. Focus, axis of the parabola, vertex and the directrix are marked. Let us now concentrate on the standard equation of parabola. To get standard equation of the parabola, consider the vertex is at the origin and the axis of symmetry is along the x-axis or y-axis. Now to derive the equation of a standard parabola, take O as a origin and OX is the x-axis and OY is perpendicular to x-axis. Now consider the focus F at a comma 0 where a is greater than 0 and the directrix is at x is equal to minus a. Now the directrix can be written as x plus a is equal to 0. Let F1 be perpendicular to the directrix and bisects Fm at point O. So the distance between the directrix and the focus be 2a. Now we have to consider another point that is P. Let P with coordinate x comma y is a point on the parabola such that PF should be equal to PB, where PB is perpendicular to L. The coordinate of B are minus a, y. Now, let us derive the formula. We know PF should be equal to PB. And how we can find PF? PF can be found by using the distance formula with coordinates P, X, Y and F, A, 0. So, substituting in the equation, we get PF is equal to root of x minus a the whole square plus y square. Now, to calculate the distance between P and B, what is PB? Using again the distance formula, we get root of x plus a the whole square plus y minus y the whole square. That is root of x plus a the whole square. Now, since PF is equal to PB, we can write root of x minus a the whole square plus y square is equal to root of x plus a the whole square. Now squaring both sides, we get x minus a the whole square plus y square is equal to x plus a the whole square. Applying the formula here, we get x square plus a square minus 2x plus y square is equal to x square plus a square plus 2x. Taking to the other side, we get x square plus a square minus 2x plus y square minus x square minus a square minus 2x is equal to 0. Cancelling the terms, and we get y square is equal to 4ax, where a is greater than 0. Hence, any point on the parabola satisfies this equation. Now, let us focus on 4 different cases of standard equation of a parabola. The first case is a right-hand parabola. The standard equation of a parabola with the vertex is at the origin and focus a comma 0 on the x-axis and the directrix x is equal to minus a is parallel to the y-axis, and the equation is y square is equal to 4ax for a greater than 0. Now, in this equation, you can find if the equation has y square term, then the axis of symmetry is along the x-axis. See the figure? And this right-hand parabola is so called because it opens to the right side as the coefficient of x is positive in this case. In this case, the curve extends to the first and the fourth quadrant, and the axis of parabola is positive x-axis. Alright? The second case is a left-hand parabola. Here is a figure. Here the standard equation of the parabola with vertex at the origin and the focus minus a 0 on the x-axis and the directrix x is equal to a is parallel to the y-axis. The standard equation is y square is equal to minus 4ax for a less than 0. Here the equation has y square term. So the axis of symmetry is along the opposite, that is, its symmetry will be along the x-axis. Here the parabola opens to the left. Hence it is called left-hand parabola. Also, the coefficient of x is negative. In this case, the curve, as you can see, it extends to the second and the third quadrant. And the axis of parabola is negative x-axis. Third case, when it comes to the up-facing parabola. Here is a diagram. The standard equation of the parabola with vertex at the origin with the focus at 0, a on y-axis and the directrix y is equal to minus a parallel to the x-axis is x square is equal to 4ay, where a is greater than 0. Here the equation has x square term, so the axis of symmetry will be along the y-axis. And the parabola opens upwards if the coefficient of y is positive. In this case, the curve extends to the first and the second quadrant. The axis of parabola is positive y-axis. Now comes to the last case, that is a down-facing parabola. Here is a figure. Here the standard equation with vertex at the origin and the focus 0 minus a and the directrix is at y equal to a parallel to x-axis is x square is equal to minus 4ay. Here the equation has x square term, so the axis of symmetry will be along where it will be along the y-axis. And the parabola opens downwards. See the figure? So, also the coefficient of y is negative here. In this case, the curve extends in the third and the fourth quadrant. And what about the axis of parabola? The axis of parabola is along the negative y-axis. Alright, these are the 4 different cases of parabola. Now, let's look into the next concept, that is latus rectum. Latus rectum of a parabola is a line segment perpendicular to the axis of parabola. It is passing through the focus and whose endpoint lies on the parabola. Here is a diagram. This is a latus rectum. Now, to find the length of the latus rectum of the parabola, y square is equal to 4ax. See the figure? We have to find the length of the latus rectum. Now, according to the definition, AF should be equal to AC. Alright? Now, AC is equal to FM is equal to 2A. Now, what is AF? AF is equal to 2A. And since parabola is symmetric with respect to x-axis, we can write AF is equal to FB, and so AB will be the length of the latus rectum. Therefore, AB is equal to 4A. So, this is the latus rectum for the parabola when y square is equal to 4ax. Let's see one example. Find the coordinate of the focus axis, the equation of the directrix and latus rectum of the parabola y square is equal to 8x. So, here the given equation involves y square term. So, we can understand that the axis of symmetry is along the x-axis and the coefficient of x is positive. So, the parabola opens to the right. Now, comparing the equation y square is equal to 8x with the standard equation y square equal to 4ax, we can write 8x is equal to 4x. From this, we can get the value of a, that is a is equal to 2. Now, the focus of parabola is at a comma 0. This is standard. So, substituting the value here, we get focus is at 2 comma 0. Now, what about the directrix? Directrix lies at x is equal to minus a. So, therefore, this is equal to minus 2. Now, what about the length of the lattice rectum? For a standard parabola, y square is equal to 4ax. The length of the lattice rectum is equal to 4a. Substituting the value, we get length of the lattice rectum as 8. And this is a figure corresponding to the problem. Let's see another problem. Find the equation of the parabola with vertex 0, 0 and the focus at 0, 2. Here the vertex is at 0, 0. The focus is at 0, 2, which means it lies on the positive y-axis, right? Therefore, the equation of the parabola is in the form x square is equal to 4ay. Mark it as equation number 1. Now, substitute a is equal to 2 in this equation. We get x square is equal to 8y. So, this is this equation we got as x square is equal to 8y. Alright. Now, which conic section has 2 fixed points and 2 foci? When both these foci are lies on a single point, then we can get a circle. Now, let's wind up the section with a summary.
Manorama Horizon. Learning made simple.